Hello students, welcome to my channel Elite Maths class. Today's topic is determinant. This is actually my second video on determinant. So if you are watching first time, first go through the link given in the description box for the first video. In that video I have discussed what is a determinant and what are the ways of expanding or what are the process to find the value of a determinant. Now in this video I will describe another technique or another method of finding the value of a determinant of order 3 and some properties of determinant. Now see, the first question is find the value of the determinant. First I am finding the value by using this this method is called minor method or Laplace expansion method. Minor method or Laplace expansion method. That method is described in my previous video. By this method, first let us find the value. For a 3 by 3 determinant, these are the sign of it, sign of the position plus minus plus minus plus minus plus minus plus. To find the value, I am expanding by the first row. You must write here expanding by first row. I am expanding by first row. As you know, there are total 6 ways to find the value of the determinant. So while expanding by first row, you have to see the sign of the first row, plus minus plus. So the first position, first sign of the first position is plus. Plus you have to write, or you may not write, no need to write. See the first element, it is 2. Then the position of 2 is 1 1, that is first row first column. So you delete first row and first column, then what remains? These 4 elements. You write the 2 by 2 determinant 1 2 4 2. Then the sign is minus and this element is minus 1. Now see the position of this element, it is in first row second column. So you delete all the elements of first row and second column. What remains? These 4 elements. You write in a 2 by 2 determinant 0 2 minus 1 2. The last element is 3. As the sign is plus, you have to write plus here, it is 3. Now the position of these element is first row third column. So you delete all the elements of first row third column. What remains? 0 1 minus 1 4. That's all. Now here 3 2 by 2 determinants, 2 into, just expand. This is by butterfly method described in my previous video. Just multiply the prime diagonal elements. 2 into 2 2 minus this into this 8 minus minus plus 0, this into this 0 minus minus 2, that is it will be plus 2, 1 into plus 2 plus 3, this one 0 minus minus 1, that is it will be plus 1. So here it is 2 minus 8 minus 6 into 2 minus 12 plus it will be 2 plus it will be 3 minus 7. This is the value of the determinant. This method is called, I am telling again here, this is called Laplace expansion method or Minor's method. Now see another shortcut technique. This is called SARRUS method. Also the value of the determinant will be same as usual. So here just you remember the value. What is the value? It is minus 7. Now let us see the shortcut method. This is called SARRUS method. We are finding the value of the same determinant, so it will be very easier for you to verify that in both the methods values are same. For this method, what you have to do, you write these 3 columns or the determinant whatever is given, that is you just write the elements 2 minus 1 3 0 1 2 minus 1 4 2. Then what you have to, you just repeat the first row first column and second column again. After writing all the 3 columns, then you repeat first column again. So it is 2 0 minus 1, then repeat second column, minus 1 1 4, minus 1 1 4. By this you can remember. So here we have written first the given 3 columns, that is the given determinant, then you repeat the first column in the 4th position and the second column in the 5th position. Now in the next step, what we have to do, see the technique. You this is the middle column, see in the left side there are 2 columns, in the right side there are 2 columns. So you start from here. See, from starting this you diagonally draw a line, then from this element you draw a line, then from this element you draw a line. Here what we have to do, we have to multiply all these elements. Clear? Again to that side you start from here, again from the middle position you draw a line, then from here you draw a line, here you also draw a line. What we have to do, we have to do all the elements multiply. Now in the second step, put a negative sign. This is the process, put a negative sign. Then see, by multiplying all these elements, what we are getting, 3 into 1 into minus 1, it is minus 3, plus, then multiply all these elements, 2 into 2 4, 4 into 4 16, plus, you may write like this, plus, all the product will be plus. Now here minus 1 into 0, so it will be 0, then here it is plus, then you write these elements starting from here, 3 into 0, 0 is there, that is product is 0, plus, now say minus 1 into 2 into minus 1, so it will be 2, plus 2 into 1 into 2, 2 into 1 into 2, so the total product is 4. Now see, here it is 16 plus 0 minus 3, that is plus 13, here is a negative sign, so it is minus 13, plus 0 plus 2 plus 4, 6, what remains, minus 7. See, the value is same as the previous one. So by which method you are finding the value will automatically be same. In this way you can find the value very easily or very in a very short time. So these are very useful for especially entrance exams. In that case you have to find out the value in a very short time. So this method is SARRUS method. This is a shortcut technique to find the value of a 3/t determinant, and that was the Laplace expansion method or minus method. In that way you can also find the value. So these two methods are there. For higher order determinants there are many more methods. So actually up in your class 12 syllabus up to 3rd order is there, and this is actually included in any board syllabus, whether it is any state board, CBSE or ICSE, ISC, in every board syllabus determinant matrix is there. Now let us study some properties of determinant. Now let us see the properties of a determinant. There are 5 or 6 properties of a determinant which are very useful, very helpful for solving the problems. The first one is, if the rows and columns are interchanged, then the value of a determinant remains unchanged. That is, see, there are rows and columns, and in a determinant always number of row equal to number of columns. So whenever the elements of the columns are written according to the row, that is, you have to write all the row in column, and automatically all the columns will be changed to the rows. That is, we have to interchange rows into columns, and automatically columns will be row. In that case the value of the determinant is unaltered. Clear this? Whenever rows and columns are interchanged, the value of the determinant is unaffected. That is, this is actually the concept of transpose. Whenever we are changing the rows and columns, then we are getting a new determinant. This is called transpose. This one is a part of matrix. In matrix I will discuss that one. Now see, by an example, what the meaning of the first property. Let us take a determinant, say it is 2 3 4 minus 1 0 2 5 3 1. This is a given determinant. By expanding you can find the value. Now what this property says is that this is equal to, Now see here, the first row is 2 3 4. We have to write this in the first column. 2 3 4, here it is first row, here it is first column. Minus 1 0 2 is the second row. Minus 1 0 2, here it is second column. Here 5 3 1 is the third row. We are writing in third column. See here, the first column, here it is first row, second column, second row, third column, third row. Automatically columns also changes to rows, rows it changes to columns, but in both the cases value of the same, whatever be the value is. If it is 15, then the value of this determinant is also 15. So property 1 is clear. Now the second property is, if two rows or columns are interchanged, if any two, here it is any two, here all the rows or all the columns, here any two, if any two rows or columns are interchanged, then value, absolute value of the determinant is remains is absolute value, but of opposite sign. That is, if any two row or columns are interchanged, then the value, absolute value of the determinant will remain same. That is, if the value is 15, if any two row or columns are interchanged, then its value will be minus 15. Absolute value will be same, but of opposite sign. For example, say it is A B C X Y Z P Q R. This is a 3 by 3 determinant. Now what we are doing, or what the second property says, if you change any two rows, say we are changing first row and first column, sorry, first row and second row. So here second row is XYZ, it will be the first row XYZ. First row is ABC, it will be second row. Third row is unchanged, PQR. What changes will be there? There will be a negative sign. Clear? If its value is say 10, it will be minus 10. Here what operation we have done? R1 and R2 interchanged. Clear? This can be done along column also. Any two rows or columns, any two, if you change second row and second column, so second column and third column, there will be another negative sign. See this one. Now say after this, here the operation done is R1 and R2 interchange. Next we are doing, say these two column we will interchange. So the first column will remain unchanged, X A P. Now we are interchanging these two, so the third column will be second column, Z C R. Second column will be third column, Y B Q. A minus sign is there. Due to this interchange, another minus sign will be there, so it will be plus, minus, minus. Here the operation done is C2 and C3 are interchanged. Clear? Now let us see third property. So the third property is, if all elements of any row or any column, are 0. This is the very important one. All the elements, if all the elements of a row or a column are 0, then value of the determinant is 0. This is the simple technique to find the value. What this property says, see by this example. If all the elements of a row or a column, for example, I am taking all the elements of the first row as 0. So it is 2, 7, 9, 3, 1, 4. So by this property, the value of the determinant is 0. See what? There are 6 ways of expanding a determinant, by first row, second row, third row, or first column, second column, third column. If we expand by first row, then as all the elements are 0, so by Laplace expansion method all the terms will be 0, that is the value is 0. So in that case, no need to expansion. If all the elements are 0, you simply write the value of the determinant equal to 0. Now the next property is scalar multiplication of a determinant. What is a scalar multiplication? That is what happens when we multiply a determinant by any scalar quantity. Here also see by an example. Let us take K, any scalar. It is multiplying the determinant. Say it is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is a 3 by 3 determinant, and this determinant is multiplied by the scalar K. This is another important property. You may remember here, whenever a determinant is multiplied by a scalar, that scalar will be multiplied through any row or a column only. That is, in a row you have to multiply k to all the elements, either in a column, not to all the elements. See this one, whenever k is multiplied to this one, so you may write ka1, kb1, kc1, kc1, a2, b2, c2, a3, b3, c3. See this one, here k is multiplied through r1 only, all the remaining elements are unchanged. That is, you have to multiply this scalar quantity to all the elements of either a row or a column. Another thing you may see, if I want to multiply this k to the second column, then what will happen, or what we will get? A1 first column unchanged, second column k is multiplied, kb2, kb3, third column again unaltered, etc. Hope property 4 is also clear. Now let us see number 5 and 6. Property 5 is, if any two rows or columns are identical or same, then the value of the determinant is 0. That is, if two rows or columns are identical or same, then the value of the determinant is 0. If this happens, then no need to expand the whole determinant. By using this property, you can write that the value of the determinant is 0. Here also see this by an example. Let us see this one. Say 2, 3, 4, 0, 5, 7, 2, 3, 4. You are asked to find the value of the determinant. In a second, you can write the answer 0 by using this property. How? Now see this, the elements are 2, 3, 4. Here also the elements are 2, 3, 4. That is, R1 and R3 are same. Clear? Two rows are same. Then the value of the determinant is 0. Reason is here R1 equal to R3. Now see another example. What is identical? Say the determinant is 2, 1, 2, 7, minus 5, 8, 4, 2, 4. What is the value of the determinant? It will also equal to 0. In a second you can write the answer. The value of the determinant is 0. Reason is what? Here two columns are identical. See the first column, the elements are 2, 1, 2. In the third column the elements are 4, 2, 4. That is, reason is what? C3 is 2 times multiple of C1. This is the identical case. This is the identical case. Here two rows are same. This one is the same. Here two columns are identical, so the value is 0. So this one also very useful property. Next, last one, splitting of a determinant as a sum of two determinants. How to split or how to add two determinants? Here this one some slight different property. See, you are given a determinant. I am writing the elements in a special manner. Say the first elements of the first row are alpha a1 plus alpha 1, a2 plus alpha 2, a1 plus alpha 1, b1 plus beta 1, c1 plus gamma 1. Elements of second row are a2, b2, c2, a3, b3, c3. Now the question is, you have to split this determinant into two determinants as a sum of two determinants, or you may express as a difference of sum or difference of two determinants. So let us take, in a general case, these are plus minus. In this case, whenever you are splitting the determinant as a sum of two determinant, see, these two rows will be unchanged. So the second row will be a2, b2, c2 as the given one, a3, b3, c3. Here also a2, b2, c2, a3, b3, c3. Now see the elements of first row. Here it is a sum of two terms, here also sum of two terms, or difference of two terms. So in the first determinant you have to take the first elements, that is here the elements will be a1, b1, c1, and in the second determinant you have to take the second elements, that is here the elements will be alpha 1, beta 1, gamma 1. What will be the sign here? According to the middle sign. If all the signs are plus, then you have to write here plus. If all the signs are minus, then you have to write minus. So see here the given determinant is expressed as the sum or difference of two determinants. In the same way you can add these two determinants as a single determinant. In this case, see, if these two rows are same, here in the resultant determinant these two rows will be same, but in the first row you have to add this plus this, this plus this, this plus this, or this minus minus. Clear? From this property, another thing you can remember, whenever we add to any row or column, you simply just, this is not a separate property, say this is the given determinant a1, b1, c1, a2, b2, c2, a3, b3, c3. Here say a1 plus multiple of k times multiple of second row is added to first, that is k times multiple of second row, b1 plus k times multiple of second row plus c1 into k times multiple of second row is added to the first row, that is k times multiple of these elements is added to the elements of first row. Then what happens? a2, b2, c2, a3, b3, c3. Second row, third row unchanged. What we did here? We did addition of k times multiple of the elements of second row to the elements of first row. Now see, by this property you can split this determinant. What will be there? There will be two determinants, this one 1, and in the second one here it will be k2, kb2, kc2. Now see here, first row is k times multiple of second row, so the value of the second part, value of the second determinant is 0 by the property number 5, as these two rows are identical, or if you take k common, then the first row and second row will be same, so the value of the determinant is 0. That is, we can write this, that is the value of this determinant is equal to the value of the determinant when the elements any multiples of the any row or column is added to any row or column, then the value of the determinant is equal to this determinant. So these are the properties. Another property remains, this one is related to minors and cofactors. So after discussing minor and cofactors, I will discuss that property. These are the properties, and beginning I have shown the shortcut method of finding the value of a 3×3 determinant, which will be very useful for your entrance exam preparation. So hope this video was very helpful. Please like, share and comment, and don't forget to subscribe my channel Elite Maths Classes. Thank you for watching.